Morning, everybody. I hope the voice is audible. Right. So, yeah. In the previous class, we have completed until this, right? We have completed what is converse, inverse, and counterpositive. Let's look at the syllabus and let's get going with this. And let me just share the link in the WhatsApp group. 1 second. Right. I'm still having a little cold, by the way. If you don't mind. Yeah, we are here, right? So tautologies, equivalence of formulas. Shall we continue here or yeah, I think it's better to continue here. Mhm. Well, yep. So let me just bring out my notes. Yeah. So let's just do a problem on tautologies, contradiction, and contingencies. Right, I'm not trying to do more problems here because there is not much time, but let's do at least one problem per topic. So P and P implies Q implies Q. Alright, we can actually do this by the truth table method because there are only two variables present here. So we will take P and then we will take Q and we will follow the brackets. Right, we will solve the innermost bracket first. So we will first do the P implies Q and then we will do the P and P implies Q. And let's call this A and then we will do A implies Q because I cannot write the whole thing here. So there are four possible cases: true and true, true and F, false and true, false and false. And so P implies Q will be false only on TF case, remaining cases it will be true. So TFTT is the answer for here. And you need to do an AND with this P. So when both T and this are true, it will be true. TF will be F. FT, it will be F. FT, it will be F as well. And now you got to do this whole thing implies Q. So T and T is T, right? Start from here and go to here. F and F is T as well. F and T is T as well. F and F is T as well. Because there is no TF case here. So this is a tautology. Right? Because all the cases are true. So and that is how you do it. And if you try to solve the remaining problems as well, they are as simple as that. And let's do a four variable one actually. P implies Q by implies R or S. So the columns are pretty simple. First you got to do P, Q, R and S. It's four variable, right? and then you can do P implies Q, and then you can do R or S, and then you can do, let's call this A, and let's call this B, and then A by implies B. And this is going to be a pretty long one, but try to solve this. So T, 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 F, T, T, F, T, 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 F, F, T, F, T, T. Right, it's just like writing binary numbers. Once you understood the sequence, it's pretty easy to do. T, F, T, F, T, F, F, T, T, F, 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 T, 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 F, T, T, F, F, T, F, T, F, T, F, 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 T, T, F, F, T, F. Okay. This thing is going to be long, I see. FTT and then FFFT. Finally, FFF. So we should be getting 16 cases 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, we got them. So P implies Q. That means the first implies second. Right. So all of these are going to be true, by the way, because after false it will be only true. Either FT or FF it will be true only. And the TF case is going to be an F. TF is F. TF is F. TF is F. And TF is an F. And these four are true. Cool. We will write that. Okay. Yeah, I think that's perfect. T. And then after we got an R or S. So R or S, T or T is T. T or F is T. F or T is T. F or F is F. Let's just write the false cases actually. This is an F. And this is an F. And this is another F. So T, T, and T, and T, 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 and T, T, T. Yeah, I think okay, that's understandable. And then you gotta do a by implication for these two things. So it's either TT or FF. TT, TT, TT. Here TF that means F, FT that means F, FT that means F, FT that means F, FF means T, TT means T, TT means T, TT means T, TF means F, TT means T, TT means T, TT means T, TF means F. So what we got here, this thing is a contingency. This is a contingency. 3 T's, okay. 3 T's and an F. Okay, 3 T's and 4 F's. Yeah. And again 4 T's and an F. Okay. And then 3 T's another F. So this is how you solve more than two variables to see whether it's a tautology or contradiction or contingency. This thing is over. Equivalence of formulas. Let's see. Okay, I forgot to pop out the chart. I don't think anyone's gonna come this morning, but yeah, we gotta do that. I don't know. Yeah, we gotta do that. Yeah, someone actually came. Tarun. I don't know. Good morning, man. Yeah, I just thought of popping out the chart right now. Yeah, I'll see the chart once every 15 minutes, I think. So if you got any doubts, you can post. If you got anything to say, you can say that as well, but I'll only view after 15 minutes. And what else we got here? Okay, so did we see duality? Yeah, the duality is after equivalence formula, I see. Equivalence formula. So equivalence P and Q are said to be logically equivalent if P implies, by implies Q is a tautology. So whenever P is true, the Q should be true, and whenever P is false, the Q should be false. If they are in that relation, then you can say P and Q are logically equivalent to one another. So let us look at an example. I think you guys, okay, let's look at a truth table example. P implies Q by implies negation P or Q. So the thing here is this is one part of the equation and this is another part of the equation, and whatever the truth values this thing is having, this thing should also have the same truth values. If they both have the same truth values, then you can say both of them are logically equivalent. So you take P, you take Q, you take P implies Q, you take negation P, you take negation P or Q, and then you compare this one to this one. T, 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 F, F, T, and F, F. P implies Q. In the TF case, it will be false, and the remaining cases it would be true. And negation P is FFTT directly. And negation P or Q, F or T is T, F or F is false. T or T is T, F or T is T as well. So if you compare both these rows, columns, it is TFTT and it is TFTT as well. So both of them are logically equivalent. This is actually the famous implication law. You are supposed to know this. When you solve problems without constructing the truth table. Okay, and all the remaining problems are similar. You can just check the answers. If you got any doubts, you can post it. So let us duality. Okay, before duality, there were some laws. Some laws you should know. So, okay, the names are pretty complicated here. P or T is P. Let's say T or T is equals to T and F or F is equals to F. So this is a valid statement, also known as idempotent law. And P is also P, right? F and F is F. T and T is T. So these two are called idempotent laws actually. And you know associative law, you know commutative law, you know distributive law, and I'm not going to say those things now. So P or F is equals to P because T or F is equals to T, right? It actually is the same value as P here. If you took P as T, and if you do F or F is equals to F, it is again the same value of P. So P and F is always F. No matter what the value of P is, P and F is always F. And P and T value depends upon P actually because T and T is T, F and T is F. And do we also have P and F, P and T, P or F? P or T is always T because F or T is T and T or T is T as well. These comes under actually identity and domination laws. You can refer what laws or what in the notes. I'm just trying to explain them here. Idempotent laws, identity, domination laws. So distributive law and P and negation P is always false because if one is true, the other gotta be F. P or negation P is always true because if there is one F, there should be another T. If the P is T, then the negation P is F. So there should be one T in this and there should be one F in this. That's why this is false and that's why this is true. And the De Morgan's law, negation of P or Q is a negation of P and negation of Q. The OR becomes and the AND becomes OR. Negation of P and Q is equals to negation of P or negation of Q. It just reverses when it goes into the brackets. And we also have the double negation. The negation of negation P is equals to P. The negation just cancels out. Just like minus into minus is plus, this works as the same. And let's get going. Yeah, I mean, these are some laws that you should be knowing. If you don't by heart them on purpose, you will get them intuitively when you solve a lot of problems. All right. And without constructing the truth table, you are supposed to prove this is a tautology. P and Q implies P or Q. So this means this statement should be true regardless of what you do. So first there is an implies. The general rule is to remove the implies by using the implication law. The implication law states P implies Q means a negation of P or Q, right? So this thing is entirely P and this thing is Q. So negation P and Q or P or Q. And here you use the De Morgan's law and you are supposed to distribute it. Negation of P or negation of Q or P or Q. All of these are ORs here, so there is nothing to worry about. And you can join them negation of P or negation of Q or Q. And this is true and this is true. So the resultant is true. So it is a tautology. Got it? And here is second one is pretty large. I think we are supposed to do that. Okay, this is some hectic task. P or Q and negation of P and negation of Q and negation of R. Wow. So this is actually the first term, or negation of P and negation of Q, or negation of P and negation of R. Right. Okay. So how to approach this problem in the first place? So this is an OR here, this is an OR here. If you just proved one of them are true, then you can say the entire statement is true. But okay, that is how it is happening actually. and this is an AND. Yeah, that's what I'm thinking. This is an AND and this is an AND. That's not how it works. So this is actually an OR. And pretty common. There is nothing to remove from implications here. So then what you gotta do? You gotta see if you have De Morgan's law applicable anywhere or if you have distributed law applicable anywhere. Actually, you have a distributed law applicable here. So let's do that. P or Q is the first term and negation will be there. Negation of P or negation of Q. Sorry, negation of P and right. The R will be in the middle. Negation of P and negation of Q or negation of P and negation of R. Okay, so this is how you distribute it and there will be a whole bracket for this as well. So let's just look at the first term actually, P or Q, and so negation of P and negation of Q. I'm thinking this as one term and this as another term and this R becomes un, and again you will get another negation of P and negation of R. So and again you apply De Morgan's law for this and De Morgan's law for this. P or Q and this becomes P or Q or P or R. So the double negation cancels out. I'm not writing that step again. And P or Q and P or Q is P or Q. Just writing the common term again. P or Q or P or R. Right. So that's basically P or Q or R. The first one is this. That's it, right? And okay, now let's do this part actually here. I'll use another pen for this. And so that's negation of P and negation of Q or negation of P and negation of R, right? If you see here, negation of P and is common. So can you write this? Yeah, okay. Let's do something else actually. Instead, I'm actually trying to solve this without looking at the book, so it might take some time. So what do we do here? Let's common out that negation of P or Q or negation of P or R actually, right? And if you common that negation out again, you got negation of P or Q negation of P or R. I mean, applying the reverse of De Morgan's law here. So, now there is. I'm thinking of making this as negation of P or Q or R. If you do that, then you can do an OR for both of this and it will come out as tautology. I'm thinking of making it that way. Um, okay, let's just look at the answer. The first thing came out as to be P or Q and P or R. So we messed up with an and or R somewhere. We messed up the first one actually. P or Q and negation of, right? Yeah. And negation of P and negation of Q, okay? Negation of P and negation of R, you use the distributive law, and then, and so you just distributed this negation into by using De Morgan's law, negation of P and negation of Q and negation of P and negation of R. So this P and Q remains the same, and we got so you distributed this again, P or Q. Okay. Now I see that. Why this sun became or here? You already distributed it, right? The sun was distributed, and I thought I was distributing this again, and I made this and as well. Yeah, that's those small mistakes cause a lot of problem actually. So this remains as an and, by the way. And now let's see this. P and Q and P and Q is, I mean, PRQ and PRQ is PRQ, and this is an and PRQ. So yeah, now it's working out great. Okay, because that's why you gotta look and write carefully everywhere. So the P R is common, Q and R. This is what you got. And if you look at here, negation of P, R, Q, and R. So if you think as this whole thing as X, then this is negation X. And X or negation X is always true. That means this is a tautology. Cool. Yeah, just be careful while applying the De Morgan's law. I mean, if you have written it in a more spacious place, you could have gotten the mistake. I have written it in a more compact place, so maybe that might be the reason, or yeah, I might really did a mistake. Anyways, so duality. Okay. Yeah, we completed equivalence of formulas and tautological implications, and then we came to duality. All right. So the duality, suppose there is something like P or Q, then the P and Q is said to be dual. So like all you gotta do is replace and with or and or with n. And if you have a T, then replace with F. And if you got F, replace with T. For example, dual of let's say this statement P or Q and R. The dual of that would be P and Q or R. I just replace the R with N and with R. That's it. And the dual of negation of P and Q or T. If you look at this, the negation won't change, by the way. The negation of P or, and Q, right? It becomes RQ. The RT becomes and F. That's it. And that's how you do the duals of a statements. That's mostly about it. Yeah, we got tautological implications. Yeah, equivalence means there should be a by implication, and tautological implication means the statement formula X is said to be tautological, implying a statement formula Y if and only if X implies Y is a tautology. For example, consider this. P implies Q implies negation of Q implies negation of P. This is actually contrapositive, and we are supposed to prove this in the tautology. That means, what do we do here? Yeah, we prove this. We prove this and we prove this. In a equivalence formula, if we just prove the LHS one thing, the other thing will be proved. But here you need to prove both of things. So just use the implication law. Negation of P or Q implies negation of Q or negation of P. So that's negation of P or Q implies Q or negation P. Just rearrange this term. This is same as negation of P or Q because the commutative law applies. So hence proved. This is contrapositive, by the way. Contrapositive, if you remember. Inverse, converse, and contrapositive, we have studied them, right? And normal forms. Wow, it's almost been 40 minutes since we have started the class. And I'm not feeling the time. So normal forms. By constructing and comparing two tables, alright. Some simplified forms. That we use to compute statements with more variables. So as the number of variables increase, the number of columns or rows that you need to do for a truth table increases. So the computer cannot handle them. So we use normal forms to simplify them. The computer can do them better than this, and also we can do a better job than constructing the entire truth table. For a 4 variable truth table itself, it took like 16. Yeah, this took like 16 rows, and if it is 5 variable, that is 2 power 5, 32 rows it will take. If it's 2 power 6, it's 64. So it is growing exponentially. We cannot do that practically. So that's why we got this normal forms. All right. So there is elementary product. And we got elementary sum. And we got a DNF. And we got a CNF. Let's see what these things are. Elementary products. Elementary means like let's say two propositions, right? And these are connected by a product, that is and two propositions connected by a sum, that is elementary sum. And DNF stands for disjunctive normal form. So CNF stands for conjunctive normal form. If you remember from the previous classes, disjunction means or and conjunction means and, right? So these needed to be connected by or. So if they needed to be connected by or, they needed to be sum. So it is like this actually. These are connected by or. These should be connected by or. This is or itself. So it will come as CNF actually. Yeah. So what I'm trying to say is it should be like this form. P. Oh my god, why am I writing a run for this? P or Q or R or S like this. So the P can be an elementary, since this is a sum, it should be product. So this can be P and Q, and this Q can be negation of P and Q, and this R can be P and negation Q, something like that. So these needed to be connected by OR. That is DNF. And the CNF, as you can predict, just the exact opposite of that. Right. So it is of the form P and Q and R and S. So the P can be, since this is a product, it can be an elementary sum. So it can be like P or Q and negation P or Q. So that is Q here. And R can be P or negation Q. And you got another and the S can be negation P or and negation Q. So you can have this. I mean, this form is called CNF. So basically what I'm trying to say here is for DNF, they are connected by a disjunction. What is disjunction? It's an OR. If you connected them by a disjunction, it's an OR. And for a conjunction, if you connected them by a conjunction, it is CNF. It's as simple as that. So now there are rules to obtain DNF and CNF. Okay, if we wrap this up after DNF and CNF, this whole thing will be remaining for us. I think it will take another 2 to 3 classes. Yeah, I will wrap this up after DNF and CNF. I don't know, my eyes are paining a lot. And also I need to get the groceries. So the step one is to remove implications, and by implications we have laws for them. P implies Q is equals to negation P or Q, and P by implies Q, actually P implies Q and Q implies P. Right? So by using these laws, just you remove the implication by implication and use De Morgan's law to distribute the negation. So if there is something like negation of P or Q, then you write something like this. You just distribute it and do it like this. Right? It need to be as simple as possible. No complicated brackets. And after this, if you still have, let's say for DNF, if you didn't get the DNF form, apply distributive law until you get the required form. Until you get the required form. I don't know, for some reason I'm really liking this ink pen, right? It is giving a lot of texture, like thick and thin by the strokes. Okay. And let's look at one example for DNF and CNF both. Let's look at a complicated example. Yeah, let's do this. Negation of P or Q by implies P and Q. So we have De Morgan's law here. We have by implication law here, and I think we got to use the distributive law here as well. So let's get this started. So first you remove the by implication. So you take this entire thing as P and you take this entire thing as Q. So it will be P implies Q. That means negation of P or Q implies P and Q. This is the first term. And so Q implies P, right? P and Q implies negation. I think the extra bracket is unnecessary. Negation P or Q. Ah. So now you gotta use implication law to simplify it further. So the implication law, this is P and this is Q. So P implies Q is negation of P or Q, right? Negation of P or Q. I mean, applying negation for this whole thing, or Q. Q is P and Q. And this is first term actually. And you got to apply the implication law for this as well. Negation of P and Q, or Q is negation of P or Q. And now this negation is for whole and this negation is for whole. This cancels out. P or Q, or P and Q is the first term. And now you distribute this using De Morgan's law, negation of P or negation of Q, or and distribute it again, negation of P and negation of Q. Right. I think we got something here. So we are trying to get what are we trying to get here? DNF. We are trying to get the DNF here. That means disjunction. That means they should be connected by an OR. So this is connected by an OR. Okay. So this is an OR and this is an AND. So you can distribute this, right? So you can distribute P or Q or P and P or Q or Q, right? And the common terms will just cancel out. And again, same here. Negation of P or negation of Q or negation of P, and this end, I'm distributing it out. Negation of P or negation of Q or negation of Q. If you do this, it is just P or Q. I mean, you can just remove the common terms. And are you supposed to have an and in between? Okay. You are actually supposed to have an OR. So you should be distributing the OR. Gosh. Am I trying to do the CNF for the DNF? So until where did we get it, man? I just cancelled out the double negation. P or Q, or P and Q, okay? And negation of P or negation of Q, or negation of P and negation of Q. Okay. So what I'm trying to say here is, yeah, let's try to continue. All right, let's see where this goes. And we got again a P or Q, and we got negation of P or negation of Q, and negation of P and negation of Q. Wow. How beautiful is this? And this just comes to one term and this just comes to one term. But you got an and in between. So this is not how you do it. Okay. So how do you do it? By the way, the same procedure until here, for regardless of DNF or CNF, you remove the by implication law. I mean, this came as to be CNF form. We are trying to do a DNF form, right? That's why this is not the answer. But I'm not saying this is incorrect. This is correct, but this is not the question that was asked here. Right. P or Q or P and Q and negation of P or negation of Q or negation of P and negation of Q. So here, this last step, okay. Right. So this last step is how you do for a CNF. But to do for a DNF, let's see what we got. So we gotta make this DNF. That means DNF. All right, my brain is not braining now. So it should have an and in between. This is how it should be. This all should be simplified to an or expression. Got it? So how do you do that? So let's say P or Q is another one term, and you take P and Q as another term. This is one term, this is one term, and this is another term. So you can apply associativity law here, right? A or B or C form. A or B or C form. So the brackets are currently like this, and you can apply the brackets as A or B or C, like this as well, right? So P or Q or P and Q. So and also you can reshuffle it, right? P or Q. Okay. So the Q or and Q1 just get cancels out. So from here it is just Q. How is it just Q? Because let's say there are only two cases, right? This is either true or this is either F, right? And T or T is T. If you take these two, that is actually the same as Q. T or F is also T. So regardless of the value of this value comes out to be Q, right? I hope you have understood, because this is an OR, this doesn't matter. We have converted into the required form, and the and will be preserved in between, and you do the same here. So how do you want it? You want it as P or Q form here as well. So you just take this as 1, just like how you have taken here. You will take this as 1, and you will take this entire thing as 1. So negation P or, and I'm just using the associated law here, negation of Q or negation of P and negation of Q. And again, this thing doesn't matter. It just comes down to the value of negation of Q. So it is P or Q and negation of P or negation of Q. Okay, don't give me that face, man. That's it, right? Yeah, that's it. I mean, this is the required DNF, is it not? Oh, wait a goddamn second. This is what? This is or connected by an and. So and means conjunction. So this is conjunctive normal form. So what is that? What is that thing that we have done earlier before? But that's not. If that is the disjunctive normal form, the answers are not matching actually. Oh gosh, these things confusing me. And the battery's out as well. Um, so shall we just use the distributor here? What did we do here before? Actually, we can distribute this answer to get the required DNF, but we will try to do it in the other way as well. So this is just, I mean, this is just normal distributor. You can think of as entire A and B or C, right? So that will become A and B or A and C. So if you do that, it will be P or Q and negation of P, or P or Q and negation of Q. And if you apply the distributor law here again, it will be P and negation P, or Q and negation P, or P and negation Q, or Q and negation Q. And if you can actually remove these terms, because P and negation P is always false, and Q and negation Q is also false. So it just comes to P and negation Q, or Q and negation P. This is actually the famous XOR law. Ah. So you got both CNF and DNF for this, but what I'm trying to do here is we came until here before. I mean, I'm trying to talk about the before way of solving this approach. I just need to know where we went wrong, P or Q, or P and Q, and negation P or negation Q, or negation P and negation Q. I just need to solve from this in the way that we have solved before. Let's see. Yeah, doesn't matter if we go forward or not. We just need this thing to be sorted out here. So what did we do before? I mean, instead of doing this, yeah, P, did you just distribute that? Yeah, you can just distribute it, right? P or Q, you just took as one term, A or B and C. So it will be A or B and A or C, right? This is, I mean, this and is inside, it came to outside, and this or is outside, it went to inside. So that's how you distributed it before. And same for this. So this is entire A or B and C. So that's negation P or negation Q or negation P and negation P or negation Q or negation Q. That's what you did before. And then P or P is P, so that's P or Q, and Q or Q is Q, that is P or Q again, and negation P is common, negation P or negation Q, and negation P or negation Q. This is what you did, right? Actually. And is this right? So like this is A and A form. This is A and this is A. A and A is A. So this is P or Q and negation P or negation Q. Right. So this is actually what? P or Q and negation P or negation Q. This is the there is an and in between, so this is the CNF. So we did it correctly. And did we do the same thing before? All right. And now you can just continue from here. Right. So you can just continue this process. I mean, because you need the things to be having an and in between, right? I mean, you just did this, right? This entire thing is A and B or C. Here we did that, right? So just do that and you will get this answer. I mean, so we haven't done any mistake before. We just got confused between the DNF and CNF. So we were right before. All right, and the battery is dying, and I gotta go. And it's nice having this session with you people. Okay. So hello, bro. Telugu. Sorry, bro. I'm trying to do this for a week in English, and I will just check the reach. If the reach is more in English, we'll do in English. So make sure the reach will be less this week. So in the next week, I'll do it entirely in Telugu. Sure. So 69 subscribers. Yeah, this is a milestone. And soon 70. Thank you, man. Thanks for the support. And hope you were not confused with this. Did you understand anything that happened in this class? Because it's kind of confusing today, but all right. Peace.